Ramya. I am pursuing my Electronics and Communication Engineering second year.
Myself Ramya, I am pursuing second year Electronics and Communication Engineering in National Engineering College.
Maheshwari. I am currently pursuing my Electronics and Communication Engineering second year in National Engineering College, Kovilpet.
I am Rifana Nasrin. I am pursuing my second year in Electronics and Communication Engineering in National Engineering College.
Hi everyone, I'm Lakshmi Ganga from National Engineering College from Department of Engineering. Our project is Wi-Fi Smart Bulb. Why we have to use Wi-Fi Smart Bulb? Yes, it has various advantages and easy remote control access for the users. So what are the advantages of using Wi-Fi Smart Bulbs? Wi-Fi Smart Bulbs are used for disabled, like they can operate from their own place and need not to take much movements, so it is easy for the disabled to access. Not only the disabled, but even people who are sick and the old age people can also use this access. Now let us look into the constructions. What are the things we use here? We use ESP32 to connect with the Wi-Fi module, and we use PIR sensor, LEDs and ultrasonic sensor to detect the motion of the people. Now let us look into the project.
This is our block diagram for our system Wi-Fi Smart Bulb. This system allows us to turn a light on or off either by ourselves or automatically using sensors. Let's start with the web server. It is the core of our system. It handles commands and sends them to the rest of the system. The web server uses something called HTTP routes. These routes let us choose between two modes, manual mode and auto mode. In manual mode, we can control the LED by pressing buttons on a web page. For example, we can turn the light on or off from our phone or a computer. In auto mode, the system uses sensors to decide when to turn the light on or off. The web server connects to the internet using Wi-Fi connections. This lets us control the system from anywhere within the network. Let's look at the sensors. We have used the LDR sensor, PIR sensor and distance sensor. The LDR sensor reads the light level. If it is dark, the system checks the next condition. The PIR sensor checks for motion. It looks for people moving nearby. And the distance sensor measures how close a person is. If someone is closer than 100 cm, it sends a signal. So if the light level is low, motion is detected, or someone is close, the system will turn the LED on. If these conditions are not met, the LED stays off. This makes the lighting smart. It saves energy and only works when needed. And we can switch between manual and auto mode easily. The system is useful for smart homes, classrooms or even offices when light should only turn on when needed.
So, I'm going to explain a simulation model of our project Wi-Fi Smart Bulb. Here we are using ESP32 to run our project by enabling an Wi-Fi Smart Bulb. ESP32 is a main controller which handles an Wi-Fi communication and gets an input from a sensor and produces an output according to what it sends from an sensors. It connects to an internet or through a Blink app to control the smart bulb based on the sensor's inputs. Then the LED here we use is access and smart bulb. This is for our simulation purpose. We keep this LED as our smart bulb. This LED is turned on or off based on the condition like motion detection, distance sensing app and the brightness control using an LDR sensors. Here we use a resistor. This resistor is used because of current limiting resistor to overcurrent that would ban out the LED. So for a precaution purposes, we use this current limiting resistors. Then a PIR sensor. PIR sensor is nothing but a passive infrared sensor which detects a motion and sends it to an ESP32 controller. Using that input, the ESP32 controller turn on the bulb. Like for example, if the man enters the house, the motion is detected by walking of a man. Then the sensor gives an input to an ESP32 controller. Then this ESP32 produces an output by glowing and light. This turns on a smart bulb when the motion is detected. Then an ultrasonic sensor. Ultrasonic sensor which measures a distance to detect the presence of proximity. It triggers a pin in an trig in ESP32. Then echo pin input to an ESP32 can be used to turn on the bulb when someone is nearby or control the brightness based on the distance. Here we use an LDR sensor. LDR sensor is nothing but an light dependent sensor. Here we use this light dependent sensor because it measures a brightness of a room or brightness of a hall and turn on the bulb according to a brightness. If the light is very less, then it turns on a bulb. If the room is very bright, it does not turn on the bulb. These all are connected to an ESP32 via connections like ESP32 has and 38 pins. Here the LED's anode is connected to an general purpose of input and output pin. Then a LDR sensors VCC is connected to 3.3 volt and it is grounded. Then output is getted from the general purpose input and output pin. Then a PIR sensor, passive infrared sensor. It gives a VCC at the 3.3 volt and the ground is connected to the ground. Then the output is get from a general purpose of input output pin from D13. Ultrasonic sensor, which is also provided with an VCC 3.3 volt and ground. Then a trigger pin, which is a general purpose input and output pin in a D12 pin, and echo pin, general purpose and input and output pin, which is in a D14th pin. These all are connected to an ESP32 and it all works based on an Wi-Fi communication.
Explanation for the code. Before that, our Wi-Fi smart bulb automatically turn on the bulb when the motion is detected. That can be measured using PIR sensor, and an object or the person is within the 100 centimeter. It can be detected by using the ultrasonic sensor, and it's dark. It can be detected by the LDR sensor. The manual turn on or off the bulb from anywhere using the Blink mobile app over on Wi-Fi. The hardware used are ESP32, the main microcontroller with Wi-Fi, PIR sensor detect motion, ultrasonic sensor measures the distance, and LDR sensor detect the brightness. Relay or the bulb that is connected to the pin 27 turn on or off. The Wi-Fi for remote control via internet. The Blink app connected to our ESP32 through the cloud using our Wi-Fi. The switch on V0 in the app let us turn on the bulb on or off manually. The ESP also sends the bulb status updates back to the app. How it internally works is the ESP32 first connected to Wi-Fi and blink. Every 2 seconds it check if it is dark, that is the LDR value is less than the threshold value, or if a motion is detected, or if anything is within the 100 centimeter. In this code, the define Blink template ID, name and token, and these are our Blink creditants. They link our code to our Blink app. Then hash include Wi-Fi client, and then Blink simple ESP32. The Wi-Fi.h for connecting to Wi-Fi, and Wi-Fi client.h for internet communication, and the Blink simple ESP32.h for connecting ESP32 to the blind code, and the character SSID, and then a password. That is, we have to enter our Wi-Fi name and password here so that the ESP can connect to the internet. And these lines, the PIR pin 14, it indicates the PIR sensor, and ultrasonic sensor which triggers an echo on pin 12 and 13, and then LDR sensor on pin 26, and LED on pin 27. The bool bulb state equal to false, and the int LDR threshold equal to 2000. This indicates that bulb state stores whether the bulb is on or off, and the LDR threshold defines how dark it must be to trigger the bulb. And this function bulb state equal to prom.int of, and digital write of bulb pin comma bulb state is triggered when you press the V0 switch in the Blink app, reads on or off, and turns the bulb on or off accordingly. And void check sensor off. This function is called every 2 seconds to read the sensor value and decide if the bulb should turn on or off. And here int LDR value equal to analog read of LDR pin. The lower the value, dark it is. And bool motion detected. If it is detected, the motion is detected, it turns to true. And here this code and sends the trigger pulse to the ultrasonic sensor, and here the trick pin comma low, trick pin comma high, and this all indicates that measures how long the echo takes to return. And here distance, that converts the time into distance in centimeter. And motion detected and distance less than 100, and LDR value is less than LDR sensor. This motion is detected, something is less 100 centimeter away. And lastly, the digital write of bulb pin comma high and serial dot print in ESP32 is alive. This shows that the serial communications, it sends the bulb on status to the app, and serial dot begin of 115200 and serial print in ASP is alive. This shows that the start the serial communication for debugging and print the startup message. And lastly, the blink dot begin, blink at token comma SSID and plan. Pass this connects the ESP to the Wi-Fi and then a blink app. And here the pin mode PIR is input, and echo pin is also input. Pin and echo as input, and trick and the bulb as output. Make sure that the bulb is off at start. And timer dot set interval 2000 L comma check sensor. It turns the check sensor function every 2000 milliseconds or 2 seconds. And the serial dart brings ESP32 is alive, extra debug message for confirmation that setup is complete. And finally, the void loop of blink.runoff and timer.runoff. It keeps the blink connected and runs the timer to check sensor periodically.
We have used ultrasonic sensor, LDR sensor and PIR sensor. Once the motion is detected, the bulb will turn on. If any object comes near to ultrasonic sensor, the bulb turns on. If the light is incident on the LDR sensor, the bulb will turn on. This is our project.